in the context of CIRS, what the research has sort of shown is that there seems to be a genetic susceptibility component, and it seems to be tied to the HLA system, the class 2 system, and chromosome 6. And the inference there has been that there is, in these people, which we think it's about 20 to 24% of the population, at least in the US, that there is poor antigen processing involved, and that's what makes these people susceptible. I don't think we fully fleshed that out in terms of, is it that you're kind of born already with an impaired system for clearing out certain kinds of antigens when you encounter them in the environment? Or is it that depending on sort of the metabolic state or the functional state that this can shift? And we do see acquired aspects of this where you start seeing deficiencies of T cells and B cells, and it's like suddenly they don't seem to be producing antibodies to, let's say, a tick-borne infection when in fact there is a tick-borne infection. But so it is, I guess I'm bringing this up because it is a bit of an ongoing discussion. So there, we've identified a genetic basis for the illness in terms of susceptibility. It's not fully fleshed out how that, whether it's something that you're born with an inability to clear certain kinds of biotoxins from the environment, or whether this just something that gets triggered over time and then you can sort of reset it. It might be a combination of both, I think.
Well, the human body has a lot of adaptability. Okay, it's a matter of creating, because it's going to adapt to the circumstances that you present it with. And yes, obviously you can have genetic susceptibilities of certain diseases, but that genetic susceptibility ultimately has to find an environment to be expressed. And so you can circumvent it, even the worst ones, like the ApoE4 genotype. Like we can neutralize the ApoE4 genotype. And so even the methyltransferase mutations, okay, you can provide additional support so that those are silent for the whole life. And so the antigen production capacity, sometimes that's also, like, again, no one knows exactly these answers, right? And we're here to try to solve these problems. But what often will happen is you get a dysbiosis type situation. You see this in the gut microbiome a lot, okay, where you get a preponderance of one group. And the same thing can happen in the immune system. You can get antigens and antibodies, or they can overwhelm the other, like almost like a zero-sum game, for example, right? Like, so there's certain antibodies that will be created in excess, and it kind of uses up the space. You haven't really lost it. It's been distributed. It's the distribution of your immune system has been disrupted, and then that will take, again, time to lower that immune response. Okay, so it gradually lowers, so the other immune systems can come back up to balance. So it could be that could be contributing a lot to the overall issue.